What's up, guys? Welcome back to the channel. I hope you all are doing good. So let us continue with the backtracking problems, and we'll try to finish this backtracking also as soon as possible. I would just like to tell you that I did an interview with my very good friend from college who, from a non-CS background, has got a job in Walmart, and I have talked about his entire distinct journey and made an interview with him. It will be inspiring. Please do watch it. It is the latest video. I'll put a link also in the description or maybe in the iCard somewhere. Also, I'm making projects for resume. Please do check that out also. There's a playlist only, projects for resume. Okay. And I've made 5 different projects and I'll be uploading more in the future. So let us see today's problem. Today's problem is, excuse me, partition the array into k subsets. If you are able to solve this problem, then there is another problem, subset sum problem. Okay, this subset sum problem is basically partition the array into 2 equal subsets. So this is a general problem where we have to partition the array into k subsets of equal sum. So I will read the problem statement. Given an array of integers and an integer k, we have to check if the array could be divided into k non-empty subsets with equal sum. So if you're able to solve this problem, you can also solve the other problem, which is partition the array into 2 equal subsets. Although dynamic programming is much better over there, here we will be using backtracking. Okay. And one more thing, all elements of the array should be exactly in one partition only. All elements of the array should be part of each element should be part of one partition. So let us see what does it mean. Suppose the array is this. Okay, this is our array and k is equal to 3. It means we have to divide this array into 3 subsets of equal sum. First of all, let us calculate sum of the array. What is sum of the array? 2 plus 1, 3 plus 4, 7 plus 5, 12 plus 6, 18. So sum is 18. If I have to divide the array into 3 subsets of equal sum, what should that sum be? That sum should be 18 by k, which is 18 by 3, which is 6. That means each and every subset should have a sum of 6, sum equal to 6. Fine. So here only we can get some trivial answers, like some obvious cases where we will have no answer, or where we will have a definite answer also. For example, see, in this case, we have n is equal to 5. That means 5 integers are there in the array. Suppose k was 6. Whenever k is greater than n, that means if the number of subsets that we have to make is greater than the number of elements only, then we have no answer. Then we can't actually. We have to return false. Suppose k is equal to 1. That means we have to divide the entire array into one subset of equal sum. So one subset means we can take the entire array only, right? So when k is equal to 1, obviously we have an answer. So we have to return true or false only. In this problem, they have not asked us to find out the subsets, although that is also easy. If we know how to do this, we can do that also. Like we can print the subset also. But in this problem, we are just asked to tell if we can or we can't. Can we divide the array into k equal subsets of equal sum or not? That's all. So when k is equal to 1, the answer is of course going to be true. Now, when we calculate the sum of the array, if we find out that sum of the array is not divisible by k, in this case, see, 18 is divisible by 3. So we can understand that each subset should be of sum 6. Suppose k was 4, then we can't divide the array into 4 equal sum subsets. So in this case also we return false. So these are basically the trivial cases. Okay. Now let us see how we'll solve the problem if we can, if the cases are not this. Suppose sum is divisible by k. In this example, that is only happening, right? Our total sum is divisible by k. So we can get a subset, or we can't. We'll see how to do that. So tell me one thing. We are told to find out if we can divide the array into k equal subsets, right? Of equal sum. Equal subset means equal sum subset. Now, if at any moment you get to know you can form k minus 1 subsets, listen to me, okay? If at any moment you can get to know that you can form k minus 1 subsets of equal sum, can you directly say that we can form k subsets of equal sum? Pause the video and try to understand what I'm saying. If you have found out k minus 1 equal subsets, can you directly say that you have k subsets of equal sum? Let us see from this example. The array is this. Suppose I keep the subsets as 2, 4, one subset, 1, 5, another subset. Now I have found how many? K equal to 2, or I'll say count of my subsets is equal to 2, and 2 is equal to k minus 1 because here k is 3. So basically I have found k minus 1 subsets of equal sum. Can I conclude that yes, I can divide the array with k subsets of equal sum? Obviously, because the remaining elements will definitely form a sum equal to k. Not sum equal to k, sorry. Remaining elements will form a sum which is equal to total sum by k. That means, see, what is the sum here? 6. What is the sum here? 6. What is the total sum? 18. So 18 minus 6 is 6 only, right? So what I'm trying to say is, if at any instant you find out you can make k minus 1 subsets of equal sum with some combination of the arrays elements, then you can directly say that you can get k subsets of equal sum. You don't have to bother about finding out the other subset, because in this problem we are only asked to output true or false. That's all. So this is one thing, okay? So keep this in mind. Whenever we have k minus 1 subsets of equal sum, we can directly say that we can find an answer. We can find an answer, okay? That is what I wanted to say here. But now how do we get to know we have found k minus 1 equal subsets? So what we'll do, first I'll write the array again here. Okay, this is my array. Okay. And the sum that I have to find, let us say it is target. The sum that I have to find is sum by k. In this case, it is equal to 6. My target is equal to 6. Correct. What I will do, I will keep a variable called current sum. This current sum will be helpful in finding out what is the current sum of elements in the current subset. Whatever elements I choose in the current subset, what is the sum? Also, I'll keep a variable called count to count how many subsets have we found, have we made at least. Okay, I'll keep this variable. One more thing to note is that I need to keep a visited array. This visited array is also of size n. Why is it necessary for having visited array? See, here it says every array element should be part of one subset only. That means I should mark in the visited array if I'm considering an element. Okay, and this will be helpful in the further part so that I won't check this element, because I can't include the same element 2 times. So that is why I need a visited array. Fine. What I will do, I will traverse this array. I'll traverse the array, and I got the first element as 2. initially all the indices are unvisited. So all indices in the visited array are false. So I'll see that, okay, I have not visited 2 yet. So I will include 2 in my current sum. So my current sum will become 2. Okay. My current sum will become 2 and I will say visited. I have visited this index, so I will make it true. Okay. Then I will backtrack again. I will not backtrack. I will call the function again. Wherever this process is happening, I will call the function again and I will traverse the array again from 0. The second time I traverse, I will get to know that, okay, I have visited 2 because it is marked true. Then I will take 1 because 1 is unvisited. So my current sum, I will add 1 and my current sum becomes 3. Now, before doing this, I forgot to tell that, see, when my current sum became 2 and when I call the function again, I will check if my current sum is equal to target. Is my current sum equal to target? 2 is not equal to 6. So this condition is false. And if at all my current sum becomes greater than target, I will return false because I can't include any other element. It is not a valid combination. So these two things are there that are going to happen in every function call. So now what is it? The sum is 3. Is sum equal to target? No. Is sum greater than target? No. So again call the function, start traversing the array. 2 is visited, 1 is visited, 4 is not visited. So include 4, sum becomes 7, current sum becomes 7. Now again pass this current sum into another function. Okay, but before traversing the array again, check current sum is equal to target? No. Current sum has become greater than target now. See, 7 is greater than 6. So this is not a valid combination. So 2, 1, 4 is not a valid subset. So return false, or just return from here. Actually, just return. Don't do anything, just return. Okay. So when you return, now what you have to do in the visited array, when you visited this element 4, you had marked the index of 4 as visited. Here you have to unmark it. So visited of this index will become false. So this element is not visited now because we are not considering 4 in our combination. So 2, 1, 4 is not possible. So remove 4. Now go with 2, 1 only. Can I take 5 now? See, 4 only was not possible. So 5 also won't be possible. But in the algorithm, you have to consider. So it will happen. It will consider 5, but it is not the valid answer. It will consider 6 also. It is not valid. So 2, 1, you won't get any combination with 2 and 1. So remove 1 also. So now only 2 is there. Okay, so mark index of 1 also as unvisited. So index of 1 is also unvisited. Wherever element 1 is there, na, index of that is unvisited. Now go to 4. So make the subset as 4. Subset as 2 and 4. So my current sum will be equal to 6 now. When my current sum is equal to 6, and it is equal to target, now what should I do? See, now I have a sum of a subset which is equal to my target subset, the target subset sum. Now what I should do? I should increase my count. Why should I increase my count? Because I have found a subset having sum equal to target sum. I will increase count and I will do the same process again, but I should make sure my current sum has become 0 because now I am checking for a new subset. So I have found one subset. Okay, I'm writing it here in the left side. One subset I have found, 2, 4 is one subset having a sum equal to our target. Now I have increased my count saying that I have got a subset and I've made my the current sum 0 because now I am trying to find a new subset. So 2, 4 is done. Okay. So 2 and 4 are visited. So when I traverse through the array again, I can't go to 2 and 4. They're already visited. So I will take 1 now. I will check with 1. I'll take 1. My current sum will become, what is my current sum going to be? 1. Now 1 is not equal to target or not even greater than target. So I will include another element. But can I include 4 this time? No, because it is already visited. 4 is still marked visited in the visited array. Go to 5. So I'll include 5. What is the sum now? 6. So I have found another subset, 1, 5. Because current sum is equal to target sum, my count will become 2 now. Count became 1. When I got a subset 2, 4, count became 2 when I got subset 1, 5. Now see, count is equal to k minus 1. I have found k minus 1 subsets having a target sum. So can I say that yes, there exist k subsets having target sum? Yes. So this is the problem. This is the algorithm. Okay, this is the algorithm. What is the time complexity? Time complexity is going to be n into 2 power n. Why 2 power n? Because there can be 2 power n subsets. And into n, because with each element you are considering all the subsets. See, we started from 2. From 2 we are checking all possible combinations. Then we'll start at 1 and we'll check with 1 all the possible combinations. So n into 2 power n is the time complexity, and space complexity will be 2 power n, because at max I think there will not be more than these many function calls at max. You will obviously find a subset or you will not find a subset before only. So I think this is average. I'm not sure. Just tell me in the comments what will be the space complexity. So now I will show the code. Okay, I'll show you the code now. See here, this is our array. Sorry for that, the laptop shook. So this is our input array. This is number of elements, and this is number of subsets that we have to make. First of all, if k is greater than n, return false. There is no answer. If k is equal to 1, that means we can consider the entire array only. So we return true. Find the sum of all elements of the array. Okay, find the sum of all elements. And if total sum is not divisible by k, that means we can't have k equal subset sums. So return false. Then take a visited array, mark all the indices as unvisited, false. Then I'm keeping a variable Boolean answer. It will tell me whether I can get an answer or I can't get an answer. And I'm passing all the this thing, array elements, variables, everything into the solve function. So it is taking array, number of elements in array, k. What is this 0? This 0 is current sum. Initially current sum will be 0 only. And what is the other 0? It is number of subsets I have got, count. Here it was count, na? See here, count. So count is 0 and visited array. My target sum is equal to sum by k and the answer variable here to either get true or false. If count became k minus 1, that means I have got k minus 1 subsets of target sum. Then I will return and I will make answer as true and I will return from there. If suppose current sum is greater than my target sum, here target sum I made it as sum only, okay, because I am passing sum by k to that function. So if current sum is become greater, then we don't have any answer from the current combination. For example, when we got 1, 2, 4, here we got 1, 2, 4, right? So 1 to 4 was wrong because its sum was greater than 6. So return, don't do anything. And if current sum is equal to target sum, then in that case, you have to make current sum as 0 and increment count by 1. It means that now you have got one subset. So you increment count, and for the next subset, you make the current sum as 0. And after checking that, when you backtrack, okay, and if your answer is true, then directly return from here only. Don't have to further do the calculations. You don't have to do the further calculation, just return from here only if your answer has become true. Okay. Now you have to traverse to check if you can take that element or not. So if visited of that index is false, that means you can consider. So visited of that index will become true. That means you're considering the element in that index. Okay. And see, my current sum plus a of I. I'm adding that element to my current sum. I'm considering that element and adding it. And again, if my answer has become true anywhere, if I've got any valid combination, I will return from there only. I don't have to do any other calculation. But if I don't get any answer, for example, here 2, 1, 4. See, I had got a combination 2, 1, 4, but this was invalid. So what I'll do, whatever the index of 4 is, see, index of 4 will be 2, right? I will mark it as false again. That means I'm not considering 4. So now I'll find other combinations with 2, 1 only. Okay, that is what I'm doing here. And then finally return if you don't have any valid answer. So I also was trying this problem when I was a beginner, but I was making a lot of errors. First of all, in finding logic. So it was tough for me to finish in a short period of time. So I hope now you will be able to finish it and code it by yourself with accuracy. Accuracy is important, although you might be slow, but at least be accurate. You can improve on speed, but improving on accuracy is more important, I will say. Okay, so I hope you understood the algorithm and my thinking, at least you got it. Tell me in the comments if you have any other way of solving this problem. It will be helpful for all of us. That's all for this video. Please like the video, share it with all your friends as much as possible. Subscribe to the channel. It will really motivate me. At least leave a like. It will help the algorithm. So until the next video, take care, stay safe, keep learning, keep growing, stay tuned. Bye.